Welcome to my channel. I'm Zhangjing Xu. Let's look at the problem 46 in chapter 6. In this one, this is the last problems in the gravitational force, and it's a little bit difficult. We need to apply the Kepler's second law and third law together. See, first one, it asks us to prove this equation. What does that mean? That means there is a sun, right? And this is a planet. It moves. This is the nearest point. This is a faraway point. And first, we need to determine this ratio. See, we need to determine the speed of planet of its nearest and farthest point from the sun is equal to the inverse of the ratio of near and far distance. So it tells you consider Kepler's second law. What Kepler's second law tell you? Kepler's second law tells you these areas equal to these areas. Do you agree? At a certain time t, the planet covered is the area the planet covered is them. So we consider this as a triangle. The area about it is 1/2, and this distance Vn t times this one, the dn, the distance for nearest point. And also for these areas, we consider it's a triangle 1/2 this distance times this one. And very easily we can prove this equation. And after we prove this is ratio, right? And the next one tells us we know the Earth's distance from Sun is in this range. What that mean? This one is nearest point. This one is faraway point. So we can determine the ratio for the distance faraway point to the ratio nearest distance, right? Nearest position. And this ratio is also the reverse about the speed. See? Do you agree with this part? Yes. The next one we need to determine the velocity at the Vn and Vf. How can you do that? Now we just know the ratio Vn to Vf. How can you do that? Yes. Another thing we know is about the distance, the average distance, the Sun to the Earth. Do you agree? And then this one, the average distance for this one is the nearest one plus the faraway distance divided by 2. This is the average distance. And also the speed for the average, we can consider this is as a circular motion. The distance is covered 2 pi r. 2 pi r, this distance is covered in one circle, divided by time taken for one circle, just a period t. So this is average speed. Do you agree? Average speed for the Earth rotate around the Sun. It is this number. And also we know the ratio between the nearest point to the faraway point is 1.034. So that means we can consider the faraway point is slow and this one is faster. So faster how much? So it is if we consider the Vf as 1, and then this nearest point is 1 plus 0.034. Do you agree? 34. This is the increment. The percentage increased from the far away to the nearest on the speed is just 0.034. This percentage, and then this percentage, and this is so we can consider this is the 1. This is 1 plus this increment 0.034, and the average between them is how much? It's just 1 increased 0.0017. Do you agree? Just plus this much. So average is at the middle. So very easily we know the average. So the nearest from the average is just increase 0.017 about the average speed. And also the faraway speed compared to the middle is just 1 minus 0.017. right? This is a ratio to the average speed. And this is how we do that. After we input all the numbers inside, we get the final answer. Thank you.